Video 4-3, looking at electron configurations. Okay, now, from last lesson, you know that there are different types of orbitals and a couple rules. Every time you have an orbital, the next energy level, it repeats itself. So s orbitals, energy level 1, and you also have s orbitals in 2, 3, 4, 5, 6, 7, etc. P orbitals don't start till 2, but once you do get p orbitals, they repeat themselves in every higher energy level after that. Okay. Same with D's. We talked about F's. Then in theory, each time you jump down an energy level, there should be a new type of orbital. Okay. So total number of orbitals in that will be in this energy level. It's basically whatever n is. This is n, the energy level squared. So energy level 1, there's only one type of orbital, just the s orbital. Okay, and total number of electrons is basically 2n squared because each one of these orbitals can hold 2 electrons. Okay, this one here, you end up with 4 because there's one s orbital and 3 p orbitals. This one will give you 9 because you use one of these, 3 of these, and 5 of those, etc. Okay, now, within an energy level, think of this as like the floors in a high-rise building. Okay. Each floor can have actually more than one level. So think of it like having stairs, but they're still on the same floor. Okay. So P's will always be lower in energy level than, or S's will always be lower than P's, which will be lower than D's, and F's, and G's, etc. Okay. So these will be the lowest, these will be the highest. And remember, these are still all on the same energy level. Okay, so we would expect that in terms of how the orbitals should be arranged, it should be 1s, then the 2s, then the 2p, then the 3s, then the 3p, then the 3d, then the 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, etc. And it should work this way. Okay, so increasing energies, you should have this, then this one, then this one, then this one, this one, this one, etc. Okay. Remember, each orbital can hold up to 2 electrons. If you need more than those, if you have more than 2 electrons, they have to go to the next highest orbital. Okay. Every energy level that has p orbitals has to have 3 of them. If you have d orbitals, you have to have 5 of them. F orbitals, there have to be 7 of them. Okay, so into which orbitals would the 20 electrons from calcium go into? Okay, so there are some rules that the electrons have to follow when they start filling up the orbitals. Okay, in your handouts, you have one that's called the Aufbau diagram. Okay, memorize these rules. These 3 were written at the bottom of that page. Okay, so the first rule. Memorize the rules, memorize the person's name. These will all show up on the test. Okay. Aufbau principle. Electrons have to occupy the lowest orbitals first. So they fill from the 1s, then they go into the 2s, and then the 2p, etc. Okay. Pauli exclusion principle. No 2 electrons can have the same set of 4 quantum numbers. We'll get into quantum numbers a little bit later on in this chapter. Okay. But if you look on your sheet, those are not what it says. It actually says this: electrons in the same orbital must have opposite spins. Okay, this is the correct rule. This is what it basically translates into. Okay, and we'll talk about spins in a second. Okay, and Hund's rule. When electrons occupy degenerate orbitals, these basically mean if they're degenerate orbitals were like p orbitals when you had 3 of them. Okay. Each electron must occupy each orbital, and the spins have to be parallel, meaning going in the same direction, before they can start pairing up. Okay, so we'll see how this works. Okay, we're trying to do calcium. Okay, so we would expect that the 1s orbital should be like this, the 2s orbital should be like this. 2p's, there's 3 of them because there's 1 for each of the p orbitals. Okay, then the 3s, then the 3p, and then the 3d. And there's 5 of these lines. Each one represents a d orbital. Okay, and then the 4s. So calcium has 20 electrons, so following our rules, we have to fill from the bottom up. So this represents an electron, the arrow. Okay? And when you're doing it by hand, you may want to just draw electrons with half an arrowhead like that. It makes it go faster. So first one can hold 2. The third electron has to go up here. Fourth one has to go there. Okay. Then Hund's rule, 1 into each one. Okay. And the up and down basically represent the spins of the electrons, the directions. Okay. The down spin, meaning they have to be opposite spins. So that takes care of 2, 4, 6, 8, 10, 11, 12. Then we need to put 1 into each one, 13, 14, 15. Then we can start pairing them up 16, 17, 18. Okay. Then we got 2 more left because we need 20. So 1 should go here and 1 should go there. Okay. So this will be the way the configuration of the electrons in the calcium atom, what orbitals they're occupying. Okay. But now, if you take a look at your actual Aufbau diagram, okay, the one with the little squares on the back of it, the arrangement starts out pretty much the same: 1s, 2s, 2p, then the 3s, then the 3p, and the but instead of having the 3d, the 4s is there, and then the 3d is above it. Okay, so how does that affect the actual or correct arrangement for the electrons in calcium? Okay, the first 18 are going to be identical. Now the last 2, though, instead of going up into the 3d, the 19th one goes here instead of up here because this is the correct arrangement. And the 20th one goes there. Okay, so this is the electron configuration or the electron arrangements in a calcium atom. Okay, now, how do we write the electron configuration without having to draw the Aufbau diagram and make it really tall every time? Okay, in other words, how can we save space? Okay, so in your textbook, when it asks you to write the orbital notation, basically what you're doing is the same thing as what we just did, but instead of going vertically, we're going horizontally. Okay, so remember this. When it asks you to write the orbital notation, you need to write something like this. Okay, so instead of going vertical, we go horizontal. 1s, 2s, 2p, we need 3 of them. Okay, and then the 3s, the 3p's, and then finally the 4s. Okay, so this whole thing here is the orbital notation for the electron configuration for calcium. Okay, now, if they ask you for the electron configuration notation, the last one was the orbital notation. Okay, this last one still takes up a lot of space. So, the electron configuration notation basically just lists each energy level, the orbital type, and as a superscript, you say how many electrons are in each of those orbital types. Okay, so this would be the configuration for calcium. Let's go back, take a look. 1s, this is the orbital type, there's 2 of them. Okay, so it becomes 1s2. Okay, the next type of orbital was the 2s, and there's 2 of them. Okay, next type of orbital is the 2p. You only listed once, and there's 1, 2, 3, 4, 5, 6 of them. Okay, next one is going to be the 3s, and there's 2 of them. Next type is the 3p. You only listed once again, and there's 6 of them. Okay, so the configuration is 1s2. The next type of orbital is 2s. There's 2 of them in there. Next type of orbital was the 2p. There's 6 of them in there. Next is the 3s. There's 2 of them, etc. Okay, do not use commas in between them or spaces. Just list them all together. Okay, so use the Aufbau diagram to write the electron configuration for arsenic. Okay, first thing you have to do is go figure out how many electrons arsenic has. So look on your periodic table, figure out how many you have. Okay, and then on your Aufbau diagram, start filling them in. Okay, pause the video, plug them in according to the rules, and then restart it. Okay, this is what you should have. Okay, you had 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 1, 2, 33 electrons. Okay, now, what is the correct configuration for arsenic? When you write out the electron configuration, 1s, there's 2 of them. 2s, there's 2 of them. 2p, there's 6 of them. Okay, so there should be 2, 2, 6. 3s, there's 2 of them. 3p, there's 6 of these. 4s, there's 2. 3d, there's 2, 4, 6, 8, 10. And then the 4p, there are 3 of them. Okay, so your configuration should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. Okay, now, notice on the diagram, we expected that it should be going 1s, 2s, 2p, 3s, 3p, then the 3d, then the 4s, then the 4p, etc. Okay, you can say, well, okay, well, I'll just remember that the d's actually come after the s's over there. Okay, but there's a couple more places where you get skipping in the order. You get deviations from the expected order. Okay, now, is there a way you can memorize the correct pattern? In other words, so that you can actually duplicate the Aufbau diagram. Okay, we expected that the electrons should fill this way: 1s, and then the 2s and the 2p, then the 3s, 3p, 3d, then the 4s, the 4p, 4d, 4f, etc. Okay, the 4f's actually come way after. The 4f's don't come until after the 6s's. Okay, so what's the way that you can figure out the actual arrangement on the Aufbau diagram? Do it this way. Instead of going left to right, we go diagonally downward. 1s, then the 2s, then the 2p, then the 3s, then the 3p, then came the 4s, then the 3d, the 4p, the 5s, then the 4d, 5p, 6s, then finally the 4f, 5d, etc. Okay, so this is the way the Aufbau diagram is actually arranged. Okay, so write the noble configuration for all the noble gases. Okay, you can pause it and write it out and check back here. Okay, this is what you should have. The 1s, neon is 2s, 2p, or 2s, 2, 2p6. Argon, 1s2, 2s2, 2p6, 3s2, 3p6. Okay, etc., etc., etc. Whoops, there's more for the radon. And the review question. Why can an orbital only have 2 electrons in it at most?